Hi, my name is Cody. I'm a software engineer here in San Francisco. In this video series, we are creating a coding agent from scratch using LangGraph. In the previous videos, we made a very simple kind of agent implementation where the user basically sends in their message. It goes to a first LLM prompt that will route the user message using an if-else statement, and depending on what the LLM responds, it will either respond with write code, which will then route it to this next couple of LLM prompts, or the LLM will respond with respond naturally, and then the LLM will just respond naturally as if, it was just answering a question or saying, just engaging in some sort of dialogue with the user. And this is a really kind of simple and straightforward way of starting to understand how agents work under the hood, where essentially what we're allowing the LLM to do is to take over and decide the control flow of our application. And while our implementation is really simple, straightforward, easy to visualize, and easy to reason about, there's still some flaws with what we're currently using to implement this. One flaw is that our large language model will always follow this kind of predetermined path. And it's a very simple and reliable way of doing it, but it's going to always follow this path, and it will always write HTML code to just one single file. And, for our kind of basic version, that's all we need. It will write the styles at the top, it'll write the HTML code, and then it will write a JavaScript script section all in one page. And that's a very simple, elegant, straightforward way to do it. But as we're looking to kind of increase our agent's capabilities, we need to be able to allow our agent to do more advanced things. Eventually, we're going to want it to be able to write Python code. And what if we wanted the agent to not write all of the code just to a single page.html file? What if we wanted it to break it out into a separate file that is for the CSS styles, and then maybe a third file that's for our JavaScript logic? And what if we want our agent to be able to, maybe generate images or pull in assets like 3D.glb files or sound, MP3 files? And if we were following under this existing paradigm, all of that is totally achievable, but we're going to have to implement many new nodes with many different prompts, a lot more routers, right? So right now we have a single routing node, but most likely we'd have to make an additional routing node that could route it to doing CSS or HTML or JavaScript, and then we'd have to route back up to design and plan. And pretty quickly, our kind of elegant workflow starts to be a little more complicated, and we'd have many, many different nodes. Now, that's still a valid way to do it, and many people are building agents just like that. But if we look at this graphic given to us by the LangChain team, right now, that type of approach and paradigm is much closer to the left side, which is we're building more of a router type application. Now, it's more reliable, we can reason about it better, we can visualize it better, but as LLMs are increasingly becoming intelligent, we actually want to start to trust them more and rely on them more. And there's a whole other paradigm that we can do to really simplify our agent and yet still allow it to be capable. It's a little bit of a higher abstraction, but I'm going to show you exactly what I'm talking about in this video. And the way to think about it is through this concept of tool calling. Now, LangChain has some really great documentation related to tool calling. And one way to think about it is, rather than us having to create, 2, 3, 4, 5, 6 additional nodes in order to achieve writing CSS, JavaScript, and HTML to its own files, you can actually think of a different, more abstract way we can actually just rely on this concept that was introduced by OpenAI's API called function calling. But really, the generic term that we use across all LLM providers is tool calling. And what tool calling does is, on a very initial LLM call that we give to the model provider, we can have the large language model actually just respond with the tool immediately. And so in a way, using tool calling can actually condense this entire graph into just 1 or 2 nodes. Let me give you a really basic example. So one thing that we can do is we can import this tool decorator from LangChain core, and then we can take just a very simple function definition here, write HTML, and add this decorator at tool, and we can describe essentially what we want this tool to do. So we're going to put our description here, write HTML code to a file. We give it the file path that we want it to write the code to. Then we return just a little string. In here, we can create a little array that just basically has our function method in there. And then down here, if we go, we can basically create a LangChain run where we're going to, very similarly like what we've done in our other code, we'll create a model object for OpenAI. LangChain has this function call that we can bind the tools to our LLM model. And then from here, we'll just give it a very simple prompt where we can tell it that it's an agent that can use tools to create a web page. All code will be saved to page.html. And then when we run it, we just will invoke this LLM along with the prompt. And then in here, we'll go ahead and run this, run this Python script. We'll give it a prompt telling it to create a, let's just do a game of Snake to stay consistent. And then, so this is essentially the exact same way of doing what we've been doing with our other code, but we're just using tool calling instead of using a LangGraph node. So let's go ahead and run this code. Let's come over here, let's paste this. And what this is going to do is it's going to run our LLM with our tools that are bound to it, and then the LLM is going to respond with a couple of different options. Okay, so our LLM just responded. Let's go ahead and just take a look here. So what happened is the response that we got here is we got this AI message object back from LangChain. And then this AI message has this array called tool calls. And if the large language model decides that we should use a tool call based on the tools that we had given the LLM up here, where we had bound the tools to this LLM, basically this is telling the large language model, hey, you have some options at your disposal. The user says we want to create a game of Snake, and what you have is you have this write HTML tool. And this is one prompt that goes to the large language model. And this allows the large language model to make a decision. The large language model can either just respond with its own kind of natural thing, or it can decide to return this tool calls kind of object. And in this case, the large language model made the decision that it wants us to go ahead and call our write HTML function, and then actually formatted its output to follow the arguments that we would need in order to just go straight to this function call, write HTML, and pass in the argument HTML code, which is a string, and just run this method. Now, the LLM won't run this for us. It actually just tells us what it thinks that we should do. And you see right here that it gave us the write HTML tool with the following arguments. HTML code is the argument, the first argument, and then it gives us a string that is the HTML code. OpenAI has a really great kind of visualization of this workflow. If we pull this up here, it has its function calling right here. Okay, so they have a really great visual. So basically the developer or the user will send in a message to the large language model, including a list of tools that it can do. So for example, if the user sent in a message, what's the weather in Paris? This is the classic example, right? That everyone's probably sick of reading. They can also pass in a tool that's called getWeather, and then the model will respond with getWeather Paris, right? And this is kind of an opaque example, but one thing that can help is, like in our case, the LLM's responding with HTML code, but let's say our prompt didn't say anything about creating a game. What if our prompt said something along the lines of, hi, can you hear me? What is your name? Right, something more along this lines. Now, if we were to go ahead and run this code with the prompt that we send in as just basically something saying, hey, can you hear me? then instead of responding with tool calls, it actually just responds with hi, or it says, hello, I'm an AI here to assist you. I don't have a personal name, but you can call me whatever you like. How can I help you today? And the reason why that's cool is if we go back to our kind of original graph here, what this is actually doing is it's collapsing our complexity. It's collapsing our current implementation down to be a little bit simpler, where this is actually already kind of acting as a router. And in our workflow, we had this very clear node that was like respond naturally. But this, like, in a way, this entire graph, this entire workflow just got condensed down to one step, one LLM call. Whereas right now, we would have had one LLM call for route initial user message. Then we would have had a second LLM call for respond naturally. Or if it would have gone this other route, we would have had one for route initial user message, 2 when it gets to the design and plan prompt, and then 3 once it gets to the write HTML code. So we just condensed all that down into a single LLM prompt by creating a tool call and sending in the large language model and binding that tool call with the large language model. Then the large language model can actually act a little bit as a router. Now there is one kind of gotcha that a lot of people run into, and this was definitely very confusing to me until recently, which is the large language model doesn't actually run the code for you. All it does is it gives you back a formatted list of arguments telling you that you should run this function that the LLM responded with, and you should give it these arguments. And that's why OpenAI has this third step on their graphic here, where you actually are executing the function code. Like the developer is actually the one responsible. Like it's our own code that's responsible for actually running this function call. And then when we get the results, we could then send it back into the large language model. But now it's a multi-step process. You do still have to, in this specific example at least, you do still have to like do a follow-up large language model call. But in the example I'm about to show you, we actually won't have to do that. So there's a little bit of more code we need to do in order to actually execute this large language model call, because right now it just gave us back the input argument. So then now we actually have to go and find this HTML code function, and then we have to run this this tool right here to actually execute and write the HTML code. Now there's a couple of ways to do this. LangChain has a good guide where they basically give you a helper method like this, where we create a new kind of custom object that we call tool call request, and basically it's just going to be a dictionary where you have the name of the tool call or the function call, which in this case is our write HTML. And then you have the arguments, which in this case is a dictionary with a string and then the data input. So then what we can do is if we define that and we can define the actual invoke tool, then we can take our tools array right here that has this write HTML, and we'll make a little mapping object. We'll pull out the name, we'll pull out the requested tool, and then since we are wrapping our tool function with this @tool decorator from LangChain, it actually implements something that LangChain has called the runnable interface. And that means that you can just call this .invoke on it and pass in the arguments, and it will actually execute the code automatically. If you weren't doing this, you would have to create some sort of Python custom implementation to kind of reflect on the code at runtime to like query for the available methods that are available to you. But LangChain has a really kind of clear interface that makes this really simple if you just kind of follow their tutorials and guides and this code here, to where you can just invoke it this way. And then what's nice about that is when we get our tool call back from the large language model, we can actually iterate through these tool calls and execute it by using this invoke tool function. And I actually have a list. I have a link to the original guide by LangChain here. Let's go ahead and grab this code and put it up into our loop. Now let's go ahead and uncomment this. And now, if we run our code again, then it will go through and now it will actually invoke this this method call automatically. So let's go ahead and run this. While that's running, let's go ahead and pull up our page.html file. Oh, we need to change this prompt. Okay, let's change this prompt back to say, please create a game of Snake and make it really awesome and cool if we go to our current page.html, it's just a 3D hello world. It's not actually a game of Snake. Let's go ahead and just run this. Okay. Okay, there we go. And so you see we got the exact same result. We got the LLM wants us to call write HTML with the following arguments, and then we actually automatically went and executed this. Now you can see in here, with our version control, we now have this overwritten game because it went and it ran our tool call here at tool def write HTML. So it basically just took the input that the LLM gave us, which was this HTML code. It opened up the my local file directory, and then it wrote the HTML code directly to the page.html. So in, how many lines of code is this? 20 plus, 113, but we have some comments and things. So roughly 100 lines of code. It basically just did everything that we had spent, the last 16 videos creating, and it did it all in one single LLM call. So it took this entire graph that, took us a minute to kind of build up and think through and reason through, and it turned into a single LLM call and a single node. And what's even better about this too, though, is if we're working under this tool paradigm, now we start to have a little bit more flexibility in terms of what we want the large language model to actually do. And we only have to make very small code changes. So let me just show you how we can actually make it so that we don't just write HTML code, but we can have the large language model create separate files for our CSS styles and for our JavaScript code. So I have these two other methods here that I was playing around with. And one of them is, it's another method that has this tool decorator called write CSS. In this case, we're just going to tell the large language model that it can write CSS code to a file. Now I have my file directory path here where I want it to write this page.css, and it's in this new assets folder that we created in one of the previous videos. And I have the second one that is the same thing, where we can have it write JavaScript code as well. Now let's go ahead and take these calls and let's tell the large language model, or let's add it into our tools array. And this tools array is going to get passed in through to the large language model when we bind tools and we pass in this tools. Now there is this extra kind of parameter we can give it, which is called parallel tool calling, which essentially just tells the large language model, hey, if you want to, you can respond with multiple tool calls, so it's not just one at a time. And this is helpful for this example because if it's wanting to create a game of Snake, it's going to want to create the CSS code, the HTML code, and the JavaScript code. Maybe it wants to do that all at the same time, which for this kind of presentation, is helpful and it saves us time. There's one more thing. We actually want to update our prompt to say something a little bit differently. We just want to give it the context that it's an agent that can use tools to create a web page. And then the other thing is we're just going to tell it where we want it to actually save the assets. And the reason why we're doing this is so the LLM knows when it's writing the HTML code, it will know where to reference these correctly when it's pulling in the CSS style sheet and the JavaScript code. We're going to give it the actual name and kind of path of the files as it's creating it. We also tell it to create the HTML first, then CSS, then JavaScript. I think that makes sense just because the HTML is kind of foundational about what it's creating. And, the HTML is going to be referenced by the CSS and the JavaScript. So it makes sense to just tell the LLM they're just going to write the HTML first, as opposed to writing the CSS first and the JavaScript first. To me, that just makes sense. Cool. Now, based on all this, that's all we have to do. Let's go ahead and run this one more time. And, well, let's tell it, let's give it the exact same prompt. Let's go ahead and run this again. And now it's going to write 3 files at the same time through using tool calling. Now, again, remember, if we were doing this old approach, how would we do this? We would have to create 2 additional nodes, probably after design and plan, where it would write CSS code, write JavaScript code, and write HTML code. We might even need to route it where it goes to write HTML code first, and then it goes to write CSS code, and then it goes to write JavaScript code. So there's just kind of it's just a little bit more. You'd have to go into our nodes.py. Let's go into our nodes.py, and we'd have to create a bunch of new files. We have to create a, look at this file system right here. We got design and plan node. We've got our respond naturally node. We've got our route initial user message node. We got our write HTML code. So we'd have to create 2 new files. We'd have to add 2 more nodes into our nodes.py here in this build workflow. We'd have to create new prompts. And even then, we'd have to then be testing and debugging and doing all these things. But if you look at our output here, where our agent just barely finished running, the LLM wants us to call write HTML. The LLM wants us to call write CSS, and the LLM wants us to call write JavaScript. Now, if we go into our file system, we can see that it created this new change here, this code change to page.html. If you look in here, look at this. It has an href where it's referencing assets/page.css, which it then wrote to the file system here. And it also wrote this page.javascript, and it added it in. Let's go find where it added that in. It added it in down here. And what that means too is in the future, we could actually have the large language model just look at the JavaScript code individually, or just look at the CSS code individually, and not have to overwrite the entire HTML page if it's just wanting to make a little styling change or some change in the game logic. So it means we can actually pass in less tokens to the large language model in the future, while also cleaning up everything on our kind of workflow, much less nodes, and still getting kind of the main result that we want. So let's go ahead and just see what this game looks like. Let's open up our localhost 8000. Let's go to page. We have our snake game. Oh, game over. And there you go. It all works. It all works just out of the box. So still have that same benefit, but now we're writing to multiple files on our file system, and it's not all just to one kind of HTML master document kind of blob. And this is still a pretty good implementation. I mean, this is really good, actually. I think this is a really nice implementation. Let's go and just take a look under the hood. Yeah, and look how simple this is. Just a little HTML page. Now we have our assets/page.css, our assets/page.js, and we are good to go. Now, if we look at this tool calling code, it's only 100 lines of code, but there's actually a handful of patterns here that we can make even simpler. And there's also another question to ask, okay, so this is all just in a single Python script. Well, how does LangGraph play into this? And, what would LangGraph, how would we pull this into LangGraph, and how would we make this, actually implement this in the same kind of paradigm that we're talking about? What we're going to be doing in the next video is we're going to actually be taking this exact same concept and putting it into a LangGraph, an actual graph and node implementation. And we'll actually move our old agent into a new folder just so we can kind of document it and keep it as an archive so that people can kind of look back on it, especially if they're, following this video series. And I'll actually show you how we can have a much simpler agent architecture. And we're actually going to implement an agent architecture known as React, which stands for reasoning and then acting. So what this is going to do is it's going to take our agent architecture that, really was more of like a router, and it's going to turn it into something a lot more dynamic where the LLM will reason about something, it'll execute a tool call, it'll observe the output from the tool call, and then it will loop back into the LLM to do another reasoning step. This is a really powerful kind of interface that LangGraph creates right out of the box using some of their pre-built tools. And yet it's going to allow us to build up a library of tool calling such as write HTML, write CSS, write JavaScript that will give the large language model a lot more freedom and autonomy to kind of chart the course that it needs to in order to kind of meet the user request that the user has. So we're going to dive into that into the next video. It's going to be a pretty radical jump from where we're currently standing, which is right here. We're very far left in this kind of router idea space. And in the next video, we're going to make a big push into making our agent a lot more autonomous. It's going to be looping in back over itself. But I'll show you how that simple architecture will actually unlock a lot of capabilities down the road and actually allow us to make something that's a lot more stable and just more impressive and more capable without having to, painstakingly define every single individual router node. We're really making something that's a lot more autonomous. And this is also something that as large language models start to get better and we start to increase the amount of tools that we can hand over to the autonomous agent, it will start to just mean that we're well positioned for the future as the language models get stronger, as they reason better, and as more tools come out, we can actually connect tool calling through the MCP protocol, which is basically a way to pull in other people's tool calling implementations and just hand it over to our existing agent, such that our agent can execute on additional tool calling that we didn't even have to define. So we'll start laying the framework for that in this next video, where we refactor our existing workflow into a more autonomous agent React architecture. So thanks, and I'll see you there.